welcome back to my online teaching platform. We have a question here still relating to differentiating from the first principles. The function here is y is equal to 2x minus 3x squared, and we have to find dy dx from the first principles. It means we have to find the derivative of the given function using the first principles method or approach. So let us state the formula for finding the derivative of a given function from the first principle. So the formula here is dy dx must be equal to the limit of f of x plus h minus f of x, all divided by h as the h approaches 0. So we need to find the component in the formula. Then after that we can substitute their component, and at the end we just take limit of what you have substituted to get the dy dx. All right, so let us continue and do that. So we have the original function to be y is equal to 2x minus 3x squared, which implies that our f of x, which is the original function, is the same as x. Sorry, it's the same as y. So it's going to be 2x minus 3x squared. All right, so we also need to find our f of x plus h. So let us find that one too. So we have our f of x plus h, meaning we are going to replace x with x plus h. Wherever we see our x, we put x plus h. So it's going to be 2 in bracket open. We have x plus h inside the bracket minus 3 multiplying x plus h also in bracket squared. So we need to expand the bracket. So this becomes 2x plus 2h. Then because here is having a power more than 1, we need to expand the bracket first. So we put our negative 3 outside, then open bracket. Since it's a perfect square, it's going to be x plus h, one bracket, multiplying x plus h in the other bracket, and close it nicely. So we continue to simplify. We are going to get 2x plus 2h, then minus our 3 outside. Let us work on the bracket first. So x times x will give us x squared. X times h will give us xh. H times x will give us xh. And h times h will give us h squared, and close it nicely. Continue to simplify. We're going to get 2x plus 2h. Now we have in a bracket like them. So we have x squared, xh plus xh will give us 2xh, then plus h squared. All right, so we need to expand the bracket with the negative 3 outside. So you are going to get 2x plus 2h. Negative 3 multiplies x squared will give a negative 3x squared. Now, negative 3 multiplying 2xh will give us negative 6xh. The negative 3 multiplies h squared will give us negative 3h squared. Alright, so this becomes our f of x plus h. So we need to find our need to get f of x plus h minus f of x. Right. So let us work on that. Our f of x plus h is 2x plus 2h minus 3x squared minus 6xh minus 3h squared. All right. Minus the original function, which is the f of x. So we put it in bracket. We have 2x minus 3x squared. So let us simplify this one. So we'll be getting 2x plus 2h. Look, let's just simplify straightforward because of time. So we have 2x here minus 2x. So 2x here. So this one will cancel this. And we also have negative 3x squared minus negative 3x squared. So they will cancel out. So we are left with 2h minus 6xh minus 3h 3h squared minus 3h squared. All right, so this becomes the expression for f of x plus h minus f of x. All right, so we can now replace the component in the formula. So we have our dy dx, which is equal to f of x plus h minus f of x, but the numerator is the same as the 2. Now let us bring our limit first. So we have a limit of our f of x plus h minus our f of x is 2h minus 6xh minus 3h squared divided by the h as h approaches 0. So we can split the component to get it as a limit of 2h divided by h minus 6xh also divided by h minus 3h squared also divided by h as the h approaches 0. So we'll be getting the limit of, so this here 1, here 1, so it's left with 2. H here 1, h divided this, we are left with negative 6x. Then here to h1, h here is left with h, we are left with negative 3h as the h approaches 0. So you can now substitute the value of h into the expression or into the remaining function. So we are going to get it as 2 minus 6x minus 3 multiplying 0 because the h value is 0. So we are going to get 2 minus 6x to be the derivative of the function given. So we can conclude that our d of 2x minus 3x squared dx is equal to 2 minus 6x. Thank you for watching, and do not forget to subscribe to my YouTube channel, Math with MFA. Bye bye.